Vertex form of a quadratic. So first of all, this is all a worksheet. It is available for you online to download and then fill out. It might make your life easier if you're to do that. All of these videos about quadratics are going to use a worksheet, so it'll make your life easier if you print it. Anyway, besides that, let's start talking about quadratics. So if you remember, quadratics are going to be polynomials with degree 2. So the standard form of a quadratic, and this is something you've seen in previous math classes extensively, especially when you talked about the quadratic formula. The standard form of a quadratic is like this: y equals ax squared plus bx plus c. This is cool. It's great. It's not the best form for graphing. So we have this other form, vertex form of a quadratic. And this vertex form is another way of writing the same information, but in a way that gives us a lot more information about what the graph of this quadratic is going to look like. This form looks like this: y equals a times x minus h quantity squared plus k. Let's talk about what all these values are. First of all, this h and k, those are the location, the x and y coordinates of the vertex of this quadratic, of this parabola. So there's a vertex at h comma k. The vertex is the very bottom or top of a parabola, depending on how it's facing. This value out front here, the a value, it's the same in either form. It's the same a value. You can always change something from standard form into vertex form and the reverse direction. So this a value is the same either way. This a value tells us if our parabola opens upward or if it opens downward. If that a value is positive, then the parabola is going to open up. That means you're going to see something like the graph we have in front of us already. It opens upward like this. We say that this shape right here is concave up. Concavity is essentially these two different shapes here. This shape right here is concave up, and this shape right here is concave down. So it's like cup opening up, cup opening down. This shape is concave up. Because it's opening upward, it has a minimum. It has a minimum value. So the vertex is the minimum of the function. If the a value out front is negative, then the graph is going to open downward. So it'll look like this. This shape, as you can see right here, is concave down. And the vertex of this graph ends up being the maximum of the graph, just by the shape it is. All right. So let's look at this graph over here and talk about more pieces of it. This is the vertex, that's part of it. We have these formulas here. H comma K is the vertex. A is this value that tells us whether or not the graph opens up or down. We'll get more into it later. But there's more going on with this graph than just the vertex and it opening up or down. First of all, if we draw a line directly up the center of this guy here, let me just, you know what, I'll move this and then I'll move you. You move to here. I'll move that there and then I'll move this here and draw a little arrow. Boom. This line right here, this line up and down, this we call the axis of symmetry. Axis of symmetry. It is a line with the equation x equals h, where h is that x coordinate of its vertex. We don't typically draw the axis of symmetry in, but what the axis of symmetry is it's telling you that these graphs are symmetric about this line. So if you're taking, let's say I know for a certain that this distance right here from the axis of symmetry to the graph, if I know this distance is 2 right here, I know on the other side that this distance is 2 because it's symmetric. So that works at any point. At any point along the line, however far you are on this side of the axis of symmetry is how far you are on this side of the axis of symmetry. It's pretty cool and very useful in graphing parabolas. The point where the parabola hits the the y-axis, we call the y-intercept, which we've talked about before. The y-intercept. These places down here where the parabola hits the x-axis are the x-intercepts. So there's a lot going on here. We're gonna break it all down, but I want to review what we just talked about. This right here is the vertex form of a quadratic. A quadratic is a degree 2 polynomial. Degree 2 polynomial. The shape that a quadratic makes, the shape of a degree 2 polynomial, is called a parabola. So this shape right here is a parabola. Yeah. So sometimes we use the words parabola and quadratic interchangeably, but they are different words technically. All right. From this vertex form, we're able to easily see what the vertex is. The vertex is at h comma k. And this a value tells us whether we're opening up or if we're opening down. It tells us whether we have a minimum or a maximum because it tells us whether we're opening up or down. All right, so let's go ahead and do a few examples where we look at equations of quadratics in vertex form, and we pick out the vertex and determine whether or not the graph opens up or down and whether it has a minimum or a maximum. All right. So here we have this, y equals x plus 4, quantity squared minus 6. And let me just rewrite the vertex form right here so it's visible. Out front, where the A would be, there is nothing, which means it's a secret 1. So our A value is 1. Notice in this equation here, in this formula, now let's do blue. In this formula, it's minus h, which means that you're taking the opposite sign. If it says minus h here, we're looking at the opposite sign of what we see. Opposite sign. So our h value is -4. The k value is exactly what it looks like. It's just that number at the end. So the k value here is -6. It's not the opposite sign, it's exactly the same sign. So we have our a value, our h value, and our k value, and that's enough to answer every single question that we could possibly have. The vertex is at h comma k. So h is -4, k is -6. Because a is positive, a is 1, that means that the graph is going to open up. So it's positive, which means it opens up. And if it opens up, that means the function has a minimum. Let's look at this next one. Here, the a value, let's pull this down here. The a value is -3. That's a negative value. If a is negative, it means the graph opens downward. If it opens downward, that means that the function has a maximum. So it opens down. It has a maximum. For the vertex, our h value is the opposite sign. So this is h is equal to 1, opposite sign. The k value is exactly what it looks like. So k is equal to 5. So our vertex is at 1, 5. These next few are a little bit stranger. So C doesn't look like it's in vertex form at all because it doesn't have this x minus h portion of it. But we really could rewrite this. We could rewrite it as y equals -1/2 x minus 0 squared plus 1. Because if you simplify it, it does simplify to the same thing. And if we do it like that, we're able to much easier pull out the h and the k values. So h is 0, k is 1. The vertex is at 0, 1. The a value is this value out front. You can go back and just kind of highlight it there too. So a is equal to -1/2. Running out of room. -1/2, which is negative. Which means it opens down, which means we have a max. I draw that picture every time, right? I don't like to memorize open, min, down, max. I draw a picture. Does this thing have a max or a min? It has a max. Does this have a max or a min? It has a min. So all you have to memorize is that a being positive opens up, and you can think of like positive people are happy people. So they open up, they're concave up, and negative people are sad people, and they open down. At least that's one way of looking at it. So anyways, this graph opens down, and it has a maximum. For this last one, the first part looks the same, x minus 7 quantity squared, but there's no k value. And that's because it's an invisible plus 0. So if you don't have something written at the end there, it's going to mean that the k value is 0. H is the opposite sign, so this is positive 7. K is going to be 0. That means that the vertex is at 7, 0. The A value is 2, which is positive. Which means it's going to open up. Which means, and that's a really bad looking parabola, it means that there's a min. So the graph opens up and there's a minimum. So this is really about being able to read these values off and infer important, quick information about the graph from its vertex form, right? Because this is telling us a lot. It tells us where the vertex is. It tells us if it opens up. Having a minimum or maximum, I guess, isn't the most important information if you're thinking about graphing it, but it does follow directly from whether or not it opens up or down. So I think that's all for this video. Yeah, so for this video, that's all we're talking about. This is how you find your A value, your H value, your K value. This is what a parabola looks like. This is the vertex form of a quadratic. In the next video, I want to say that I made the next video graphing. I believe the next video is graphing. And if it's not, well, whatever video I have linked next is the next video. See you in another video. Believe in yourself. I believe in you. Bye.